Hello, everybody. Good morning. My name is Nir. This is Moshe. We'll present ourselves in a few moments. Today we're here to talk about a new initiative that Moshe and I created. And a few months ago, Moshe and I met, and we said that we have few gaps in the world of cloud security. And we said that we must invent something cool. We didn't know what it is. We just said that we'll need to sit a few days and think about ideas. So after we had a lot of fighting and a lot of discussions and long nights, we decided to invent a new idea in the world of the cloud security. And this is what we're going to present today. So just a short introduction about ourselves. My name is Nir. I'm working for NCR. I'm the CISO of the retail line of business. And also I have few hands-on capabilities. Probably you'll see that if the internet will work. Otherwise, you'll just think that I just was speaking with my hands. We also have few experience in the startup world. We're entrepreneurs in our characters. And I'll let Moshe continue with the session until I come back.
Okay, thank you. Working? Okay, thanks a lot. So again, my name is Moshe. Thank you all for being with us in this great city of Singapore. Quick introduction. So my name is Moshe. I've been in the information security industries for the last 20 years. I've been doing various roles in various places. For the last 5 or 6 years, I've been focusing on information security in the cloud. And I've been working a lot with the innovation scene in Israel. I mean, most of you probably know that we have a lot of startups, a lot of new ideas, a lot of great things are coming. And in the last 5 years, I've been looking at the cloud security issue. And this is where we're coming. We're coming from the idea that cloud needs some more enhancement. It changes the way we work, and we need to think about new ideas. But the word cloud security is a very big word. Let's try to drill down, to narrow into the specific talk, what we're going to talk about. Okay? So cloud is a big thing. We're drilling down. I'm talking about IaaS, infrastructure as a service, right? This is where somebody is giving you the infrastructure, and you're building your servers on top of it. You're in charge of everything. Compliance, hardening, installing the software, configuring. This is IaaS for you guys. Inside IaaS, again, infrastructure as a service, we have the orchestration layer. This is the layer that is basically the wisdom. This is the layer that when you launch an instance, when you launch a virtual machine, a cloud instance, it will take up a storage, connect it to your server, connect the IP addresses, volume, any other thing that is required for this server. We're going to focus on this orchestration layer. And why is that? Because the orchestration layer is one of the key components in IaaS environment, in cloud environment in general, but mostly in IaaS. This layer also has a lot of attack vectors. It also possesses great advantages for those who can use it for security. Programmers learn how to use this layer for their own good. Also, security guys need to learn how to do it. Quick slide about the cloud attack vectors. Attack vectors that are unique or emphasize about the cloud infrastructure. We have the provider administration, right? Somebody is handling our files, our data. He has employees. Those employees have access. This is one attack vector. We have the management console. It is a very wide dashboard that we have in the cloud. It has a lot of abilities, capabilities. You can do everything from there. It is a very serious attack vector. We're going to talk about it in a couple of more slides. We have the multi-tenancy virtualization, right? In the public cloud, we are not alone. We have guests with us. We have no idea if the CPU next to us is the NSA, is the hacker, your competitor, or just an innocent guy, right? Multi-tenancy virtualization. There are also attack vectors. We got the automation and API layer. Everything in the cloud is API driven. Everything you do in the dashboard, you can do by the APIs. APIs are the key for the success of cloud computing. I mean, if it's not API-driven, it's probably not a cloud application. So this is another layer that is an attack vector. A couple of slides again, we show you how people use those attack vectors. We have the supply chain, right? Which sometimes we buy a software as a service, they're installed on top of a platform as a service, which in turn installed on an infrastructure as a service. We have a lot of layers of supply, a lot of room for supply chain attack, another attack vector. Side channel attacks, attacks that use physical attributes of the infrastructure in order to gain knowledge of another system. They use CPU power pulses, for instance, magnetic fields, stuff like this in order to guess things on our hardware, not only in the cloud, but it also happens in the cloud. And we have the insecure instances. Because it's very easy to launch servers in the cloud, right? You don't have to do anything physical. You don't have to buy a computer, connect it, install it. You simply click launch. Because there are so many, it's because it's so easy to launch instances, it's become an attack vector. Why? Because we're launching instances open to the world, right? The cloud is usually, by default, an open environment. We don't bother to patch them. We don't bother to harden because it's very easy to launch them. We're saying, OK, we're going to launch this server. Just for 5 minutes, do a test, and then delete it. And this server remains alive for a longer time. And it also is an attack vector. So emphasizing this, a lot of attack vectors, we're going to focus on those three. Insecure instances, management console, and automation and API. And I want to show you how attackers are using those attack vectors. Let's do it by a story, a real story, a story of BrowserStack. BrowserStack is a company. It's a software as a service installed on Amazon infrastructure as a service application. They are basically what they do, just for the general knowledge. If you're developing, for instance, a mobile application, they will give you an environment to test your application on different browsers of different cellular phones. With that, you have to buy all the variety in the market. Early in November, last November, they got hacked. They told the story in quite details in the website, so we were able to follow it. And what happened, what is this attack was about? First of all, the attacker used a shell shock vulnerability on one of the servers. Remember the attack vector of insecure instances? Again, insecure instances happens also on premise network. In the cloud, it probably happens more because it's so easy to launch new servers. So this was his way in. When he got into the server with the shell shock vulnerability, he was managed to find an API key and use it. Remember the attack vector of insecure interfaces and APIs. Because the cloud is an API-driven, we use a lot of API keys, and we forget them at different places. The hacker found one that we forgot. He was using the API key to launch a new instance, now a server that he controls, and also whitelisted an IP address in the firewall. Automation. In the cloud, everything can be done through API, even infrastructure stuff like launching a server or opening a firewall rule, all done by API. No need to a different dashboard, no need to access different GUI. Once he was inside with his own server, whitelisted in the firewall, he found a backup disk of the application, of BrowserStack application. A backup disk, a volume, he connected to his instance. Inside the backup disk, which was not encrypted, he found the connection string to the database. Basically, from this moment, game is over. The hacker was after the username and password and email addresses, all of the PII, personal identifiable information, inside BrowserStack database. By the way, due to a mistake of the hacker, he didn't manage to get it all the list. He managed to get parts of it before BrowserStack people noticed because he created some kind of lock on the database. But it was basically a pure coincidence and probably lack of professionalism from the attacker. Usually, from our experience, attacks like this are only getting discovered a couple of months later when the information is leaking to the market. So again, all the attack vectors that we talked about are being used. Insecure APIs, automation layer, verified dashboard with a lot of capabilities, insecure instances. Those are the problems of the cloud. Those are the problems of IaaS. There's a lot more problems, right? We haven't talked about government access and stuff like this, yeah? Putting those aside, I'm talking about guys like us who wants to develop stuff in the cloud, need to pay attention for those attack vectors. And this problem is even getting worse for us who wants to deliver applications, cloud applications. It is getting worse. Why? New software architecture. We're moving from layered architecture into microservices. We're moving from once in a month delivery in a good case to continuous delivery. We talk about DevOps. We're doing continuous integration. So we are pushing the limits of the security boundaries. Also, we see less and less billing cycle. They're reducing. This means that there are servers that are up for a very small time. Combine all of these changes, the fact that we use new architecture, we are doing more changes to the production environment. Usually companies were doing production changes once a month maybe, pizza night, everybody were gathering beside the server and doing an upgrade. Today, there are companies that are doing production changes 10, 12, 13 times a day. And the billing cycle is reducing. What does that mean? It means that Google, Amazon, Microsoft, they believe that there is a market for servers that are alive for 10 minutes, 15 minutes, 1 hour, 2 hours, 3 hours. And what does it mean about security? It means that we have a problem with our corrective controls. What if corrective controls? Patch management, vulnerability management, hardening. We usually do those stuff in maintenance windows, right? But if you don't have a maintenance window because your server is alive for 10 minutes or 15 minutes or a couple of hours or a couple of days even, you don't have a maintenance window to do it. So when can you patch? When can you do vulnerability scan? When can you do all the hardening that we do periodically? A lot of our security is based on periodical maintenance window. While in the cloud, we see more and more application and more environments where environment is launched, 200 servers. They are processing huge amount of data for hours, and then they terminate. No maintenance window. No time to do vulnerability or scanning or patching. Because those servers process and die. Otherwise, you're getting billed more. And nobody wants to keep a maintenance window and get even greater bills. So we have a challenge. We need to change the way we treat corrective controls. We need to change the way we treat application production servers and the way we do hardening, maintenance, and vulnerability, and all sort of those periodic maintenance checkups. And this is where we thought we should introduce some new method. And we developed an open source software. It's available to everyone on GitHub. You can download and experiment it yourself. It's called Cloud Defigo. Defigo means resilient in Latin. And the idea here is to automate the security processes that today we do manually and slowly, and usually by maintenance window. We want to do it faster and more automated. You want something to add?
Yes. Actually, so although we spent our time to develop this tool, but we also invested some money in this product. We actually invested $5 in Fiverr to buy this logo. So we're investors also. Go ahead.
Yeah. Okay. So the idea here, again, is to automate the process of the creation and the lifecycle of the instances. Now let's drill down into a bit more details on what do we do there. Basically, those are the stages that we take care of. We're launching the server automatically. He loads, getting his security configuration from a storage somewhere. In a couple of minutes, we'll explain how. It encrypts the volumes where the data resides. Why is it important to encrypt? Why do we put so much effort on it? Usually on-premise, you don't really encrypt, right? what happens in the cloud? Encryption is one of the best controls. Why? First of all, your data tends to move. Your server dies all the time. I mean, I told you, server can be launched and terminate within minutes. The data remains because you keep volumes aside. You do snapshots, right? Remember that, you know the term. When I do a snapshot or a backup, after that, anyone, like the hacker for BrowserStack, can connect it and look for the files. The data in the cloud replicates a lot. You want to encrypt it at source in order to make sure that it will remain encrypted throughout the lifecycle of the data. And if you encrypt it, if you own in the keys, which is what we do here, you are also protecting yourself from cloud provider employee. Remember that attack vector we showed? You're also protecting yourself from a foreign government, right? They have to access you. They have to call you and ask for the keys if they want to access your data. So encryption is something we really emphasize. The cloud itself is going to encryption by default, something we never managed to do on-premise. This is where the world is going. After that, we create the encryption framework. We scan the server for vulnerabilities. And once it is scanned, we're moving it into production. Let me just give you a quick overview of the components we used. Each of these components, each of these building block, you can replace with your own components. We build it with those components, but it's definitely something you can configure and use your own building blocks. Starting from the left side, our objects we keep at Amazon S3, AWS S3 Simple Storage Services. It's an object storage. You can replace it with any other object storage you want. We use it to keep maintenance, to keep basically the configuration file. We stored the encryption keys, even though it's not that a good idea. We'll talk later on what is the different options for storing the encryption keys, but we use it basically for easy access from every instance to the configuration files. Second thing we use is Cloud Init. Cloud Init is an excellent feature for security guys. Most people who work in the cloud already learned how to use it. Us, the security guys, not yet. Cloud Init is basically a package started by Ubuntu. Now almost all other OSs support it. It allows you to launch scripts while the server loads, while the server boots, with root permissions. This means that a lot of the things that we do here, we are doing it before the server is even up and running. So we do patches and a lot of other things that you will do before the server is even alive and gets an IP address, then can be accessed. So it's a great thing if you want to configure servers automatically. We use Amazon IAM roles. IAM roles are permissions that are given to servers. We usually talk about IAM, Identity and Access Management, as a way to give permissions to users, right? IAM roles are permissions to servers. Remember the BrowserStack, the guy that hacked into BrowserStack? He used the API key in order to launch an instance and do a whitelisting of the IP address. This shouldn't have happened if they used proper IAM roles. They didn't use the permissions correctly. We are using them correctly in order to make sure that even if you take over our servers, you'll not be able to use them against us. Security scanner, again, over here we use Nessus because it was very easy for our requirements. You can use any security scanner in the market. Some of them, like Qualys, can integrate deeper into Amazon APIs and give you some further advantages. We use a very simple version. Again, we want to use the most common dominators between all environments. For configuration management, one of the things we do, we launch configuration on the instance. For configuration management, we use Chef. Those of you not familiar, an open source program, really popular for guys who are developing in Linux in the cloud. It's basically a very easy configuration management tool. You can build a recipe and then put it into a cookbook and then install the cookbook on each server you want, and it's voila, you have automated configuration. And the last thing we do in order to encrypt the data, we use a regular Demcrypt utility. You can find it, you can download on the internet. It's called Demcrypt. It's basically a volume encryption, very easy to use. not sophisticated, you can replace it with any other volume encryption tools you might have. So those are the building blocks, those are the components we use. And how do we use them? We integrate them all into the instance lifecycle. What is the instance lifecycle? It's what happens to a cloud server. It's launched, right? It's updated because you need, after you install a server, you need to download configuration, do security stuff and non-security stuff, right? Also application configuration. You need to control this instance, make sure that you have the proper tools to do now the hardening, patching, all the stuff you need. We scan it. This is our term. This server will not move into production unless the scanning is, turns out to be okay. So we scan it, move to production, and in the end, the server is terminating. For each step, what I'm going to do now is go in a little bit details. What is this step about? Then we're going to show you how it looks like when Nir will operate it from the Cloud Figure interfaces. So basically, when you launch a server, again, this is how we do it. I recommend everybody that is launching cloud instances to use something like that to automate all the configuration you need. So basically, we prepare. The first thing is to prepare. We create encryption keys. Okay, we do it by the Decrypt utility. It provides us the ability. We create permissions for the servers that we are going to launch. Nir will explain in a couple of minutes what is dynamic IAM roles he created and why do we use it. The idea here is that permissions during launch, the permissions that the server requires during launch are much bigger. You see this big list? This is the permission of the server. Later on, we show you how this list shrinks when the server moves into production. It means the server has less permissions to do things on Amazon GUI. When we launch the server basically starts to build, and then the cloud init scripts kicks in. It kicks in it automatically. It's a script that we created. It's part of the Cloud Figure, and it is responsible for creating the infrastructure. We did it on Ubuntu. The same script with minor changes can run on any other operating system. It is quite standard these days. Okay, Nir, can you show us the demo?
I hope so. So first of all, we had some internet issues, so I hope that all of the demos will work. So I just pray for that, but let's hope that everything will be fine. So, so before getting into the details of dynamic IAM roles, I just want to explain one thing. So Cloud Figure is an open source Python-based application. So I used here Django just to have kind of a management server that I'll be able to just shoot few APIs through that, and then it will be easier for us. So basically, we have here basic API that I developed. I think that that the first thing that we'll do here is so we'll need to launch the instance. So for launching the instance, few things happen. The first of them is injecting the cloud init script into the cloud. It will take a few seconds. So we're injecting that, and then it's a script that runs with specific permissions. So in this process, we're creating a machine, an instance, that assigned to specific IAM role. As Moshe explained, we have a role for this server, but we don't want that all servers will have the same role, because each server should have its own access to its own resources. We don't want to duplicate that. So I don't know how many of you have experience with Amazon Web Services. I'll just ask, how many of you have a deep experience with Amazon Web Services? Please raise your hand. Good. So I'll just explain. I'll explain it in more basic level. So basically, when you start an instance and you assign a role to that, you cannot change the role after the instance has been launched. Since you cannot do that, we decided to trick Amazon by just changing the policy inside the role. That's the idea of the dynamic IAM role. So now when we launched the instance, now we can see, I'll just refresh that. So now we can see that we have a secure instance. This secure instance basically runs in a specific remediation server's security group now. It's not in production, but we want to see what are actually the permissions that this instance have. And that's the reason why we have here an IAM role. You see that it's a kind of a GUID, and if you don't see that, I'll just get into that in a second. So I'll just copy part of that, so it will be easier for me to search. And I'll go to the IAM role. I'll just refresh that, and I'll find, oh,
You copy too much.
copy too much, no problem. That's the one. So if we'll see now the policy, you see that it's pretty long policy. Basically, the idea that we have around Cloud of Figo is that the instance is responsible for its own security. We don't want to manage it centrally in the beginning. So when you launch, you manage the security. Then it goes to the management servers after that. So that's basic explanation about what we have in the beginning.
Okay, so this was the first stage of the launch. The next part would be updating the instance, right? Remember, we don't have maintenance window. We need to do everything when the server is launched. Once the server is launched and start processing, there is no interruptions until it will terminate. This is how cloud applications today are built. Most of them, yeah, not all of them, but this is where the world is going. This is the idea behind DevOps, the idea behind microservices, to have very small bunch of servers and simply replace them when you're doing an update. So what we do now is OS update. We do it by Cloud Init again. It runs by root. It takes bash commands, so you can simply do apt-get and download all the updates at once. So once the server is up, it is already patched. What else do we do in this update? We do all the prerequisite for the software. We install all kind of software packages that we need. You have the list here. It's not that important. I will not go through this in details, but we're basically building the infrastructure we need in order to continue. We're downloading the objects that we need from the object storage. Remember, first component I talked about, we use the object storage to store data, and then we download the configuration files from there, like the Cloud Init and, like the script that creates all of it, and also our configuration management, in this case, Chef initialization files. The last thing we do in this phase of the update, we attach a volume, and we create a volume and attach it to the instance. So we will have a data disk. This is where we're going to store the data, the database, whatever applications we have. And this is the disk that we are going to encrypt in a couple of steps later.
So as for encryption, just another clarification for you. So on cloud environments, if you want to encrypt the volume of the operating system itself, it may be challenging a little bit because you'll need to have encryption key somewhere or find another magic way to put your password when you start a machine. Well, we don't want to handle that. We want to make sure that the application is installed on a dedicated volume, and then we'll be able to manage it separately and automatically, by the way. So, so for this demo, I just want to connect to the instance that we just created, make sure that it's updated, because basically we have an Ubuntu image, which is not updated. It's a clean Ubuntu machine. Probably if most of you will run apt-get upgrade, you'll see that you're installing new packages. So this is one. And the second thing, I'll just show you that we actually created a new volume. So, so the first thing, I'll just go to same place. I just want to connect here. That's good. Is that big enough? Yeah, good. So I'll connect here to this server. Of course, adjusting. And I just run apt get, almost. So we can see that we have 0 upgraded packages. So that's good enough for now. Let's look at the new volume. So the volume will be encrypted. It's not yet the stage that we get to that, but eventually we'll have here the volumes. I'll just load it again. And we'll see that we have a new volume. We created it with 1 gigabyte, but basically we can see that it's a new volume, it's already in use, and it's attached to the instance that we just created.
So this was the update stage. At this point, we have a server. It is configured. It is almost configured, sorry. It is updated. It is ready to be controlled. This is the control phase. At this point, we harness the server to our control application. Again, we're using Chef. You can use any other options you want. The idea here is we download the configuration file from the S3 bucket, and then we install the Chef client and connect it to the Chef management. Inside the Chef, we have a policy, a configuration policy. Basically, it's all dependent on 2 things. What kind of security you want, because you can do all kinds of hardening over there with those policies, and what kind of applications do you want to install. On this specific server, we can install automatically a MySQL instance on the encrypted disk, right? This is why we created the encrypted disk. And also, Chef is making sure that it's installed into the encrypted disk. It also makes sure that the encrypted volume is being created. This is stuff we left to the Chef receipt. Again, you can download this logic and use it in any other configuration management. The volume, now let's talk about the key management. When you encrypt, we create a key randomly, and then you need to keep it somewhere. If you're very conscious about security, you probably want to download the key and keep it private in an HSM, hardware security module somewhere on a safe place. If you're not that security paranoid, I mean, different organizations, different market sectors treat those stuff differently. You can keep it on an HSM on the cloud, on a different cloud, on a service. We chose to keep it inside a specific bucket, inside a specific container, inside object storage. And we created a referrer, a specific header that is required to access these keys. Again, this is not the most secure, but it's very efficient. Depending on your risk assessment efforts, depending on what you're worried from, keep the key according to your risk assessments. If you're worried about foreign governments, don't keep the key in the cloud, keep it secured. If you're banks, probably also keep it on the local network in an HSM. Software company, other sectors, industries will have this solution enough for their requirements. This is the referrer, and this we will show you how it looks like in the demo.
Okay, so this demo is also consisting from a few components. So I just want to show you that this server now managed by Chef, and on Chef we had a script that actually encrypts the whole disk. And except that, we'll need to understand where is the encryption key stored, because as we said, we have a unique bucket for each instance. We don't want to mix between the keys. That's a problem, I suppose, that most of you know about. So, so first of all, let's go to the Chef server that tries to load. And we'll wait a second until it's loading. Well, now it looks like it works. So we can see that, that we launched a new instance, and as you can see, it's uptime for 5 minutes. So believe me, that's the machine that we launched now, and not before this talk. And on Chef, we actually we can edit any run list that we want. So specifically for this server, we created a run list of encryption. Again, this is only script, you can put here installation of Apache, upgrading it, whatever you want. The whole DevOps thing can be here or on Cloud-Figo. It depends how you want to program it. So, so this is the first part. Let's go into the machine back again. Hope that it's still connected. Good. So I'll just get into the logs, because there I'll be able to understand where's my key. So I'll just get into the Cloud-Figo. Yeah, okay. And I'll just print the logs that we have. So the current log says that we have a new bucket with this name. Okay, let's go and look for that. So here we are on S3. I'll just need to refresh it again. Again. While I'm loading that, just one more thing that it's important to understand. So when using the S3 bucket of Amazon, you cannot limit the access to this bucket for a specific server. You can limit it to IP addresses, to specific properties, but you don't have Amazon resources to that, except user account that currently using that. But we don't have accounts. We have only the instance. We don't have users. And that's the reason why we created also a dynamic policy for that. What we have here is actually, let's look for that. So we have here the bucket. Basically, the only thing that we have in a bucket is a key. This bucket can be also encrypted, and we can put all of the security around that. But eventually, when we're speaking about the permissions, you'll be able to see that I'm allowing access only from this account that's running the instance, and I'm allowing the access only with specific referer header. As you can see, it's a pretty long header. Actually, it's a 512 SHA. So you probably say, so what's the problem to guess that? It is a problem because it's unique per each machine. You can reverse the Cloud-Figo to understand how it works, but it will be hard to you to generate that because it's based on the hardware that the server is running on. So you won't be able to generate the same hash because you have only partial data, unless you're on the machine, obviously. And that's the reason why we think it is secure enough, although we understand that using HSM will definitely do better job. Well, if it works, why should we replace that, right? No, we can't replace that in certain way. Okay, I'll just let Moshe continue.
Okay, so encryption keys, it's a whole, it's a big thing, where to store it, how to keep access to it. We leave that aside, we can talk about it for hours. This is one solution, pretty good for most sectors. Probably some other sectors will prefer to do something more robust. They have the option. The last thing we do, as we mentioned, I want to make sure that the server is ready for production, right? Everything should be automated. There is no time for somebody to come in, do the checklist, test that everything is okay. I want to scan it, and according to the result, go to production or go to remediation. By the way, same idea of NAC, right? Network access, network access controls that check if you're okay. If not, put you into remediation, and if you're okay, move you into the LAN. We do something similar here, only we test the servers, not the workstations. So we scan it. Again, we use Nessus. You can do any other network scanner you want. What we do, we scan the server, we check the results. If there is anything above critical, I think?
It's medium. It's a configurable threshold. You can define whatever you want. Basically, we get the results from Nessus. Well, it's easy. We have an API. And then we parse it to understand which vulnerabilities are there. And based on that, we decide what to do with the machine.
So basically, we test the result. Then after we analyze it, we decide if it's moving to the production or not, according to what we see there.
Okay, so that's kind of a pretty easy step. We must understand that here also we have the instance that launching the scan, and we don't have something centralized that actually launching it. And eventually the instance is the one who have the brain or the permissions in that case to move to production. So the list that you saw contains these permissions. So let's just, well, that's pretty simple. Let's just go into the Nessus and see what we have here. So we're supposed to see here a scan. We hope that it already finished. As you can see, I can upgrade it, but that's what we have. So we have a completed scan. I can tell you that in this scan, we don't have medium or high vulnerabilities because obviously, first of all, we already updated it. If we wouldn't update it, we would see other results. And another thing that we already added the scripts of the chef, and then you can put Apache and in the same way to make sure that it's not vulnerable. Moshe.
Yep. Last word about the scanning. Other scanner can integrate easier to Amazon environment. If you're trying this at home, you're not allowed to run scan on Amazon without requesting permission, just so you will know. Okay? It violates the terms of use. Other scanners that integrates better to Amazon API can get this request online. They file for a request to scan, get it, and then scan it. Just so you know, this is Amazon restrictions. Last thing, server move into production. If you remember at the beginning, we started with a high set of permissions for the servers. Why? Because we need to do a lot of things. Create encryption keys, put them on the cloud, attach an instance. All of those stuff require permissions. Move into production environment. All of those require permissions. Now we can narrow the permissions. What we do is basically dynamic role. The role, we are taking out permissions, leaving it to the least minimum privileges. This is the dynamic IAM role concept. You will see a very reduced role, as you can see on the slide. And the last thing we do is manage. How do we manage an instance? Basically, it's a compensating control, right? The idea here is always run and detect servers that have been launched and didn't pass through this scenario, didn't pass through Cloud-Figure, didn't pass through your checkups, through your controls. So we constantly can run it and monitor. And if somebody, by some chance, managed to get in, launch an instance, we will recognize an alert. We'll say, we have an instance here. It was not managed by the Cloud-Figure process. So this is basically the production process. Move to the production process.
Okay, so in that case, we should see now in the IAM role that we have a small list of permissions, and we should see also that the server is not in the remediation group and only in the production, right? So let's see that. We'll go to the IAM again. We saw that long list. Let's just call it again. Whoops. Now we see that we have a short list, which is basically a list that says you can get access only to this bucket. That's what limits the resource from accessing other buckets. And the only thing that you can do is read your encryption key. If we want to manage that later, we can also add manage the object, edit the object. So that's the basic thing. Let's just see that we have the production servers in place. Whoa, that's pretty big. I'll just refresh that for a second. Yeah, go ahead. I'll just reload it again. So when we'll see that it's in the production security group, that's it. So we can see that it's in a production. But the thing is that we may have few instances that are not managed. Probably would like to know about that. And that's the reason why we have kind of a pretty simple logic on Cloud Figo that goes to your chef server and to Amazon and compares the instances that currently managed. So the Nessus server is not managed. Let's look for unmanaged resources. Same API. Let's go for unmanaged resources. It gets the list, compares that, and eventually we'll get a JSON list of unmanaged resources, and that's the host name of the Nessus server. Obviously, we'll be able to translate it later, but that's what we have. Now we can take that, parse that, put it in other systems, even internal systems, and just use it.
The beauty of the cloud is the fact that because you pay for everything, I mean, you pay for every bit, everything is manageable. I mean, looking for an unmanaged server or workstation inside a large network on a traditional network for administrator is almost impossible, right? But in the cloud, because you pay for everything, you have a very good list of all your servers, and then you can compare it to other mechanisms you have in order to make sure that they are all controlled, maintained. You know them all. You know who installed them. So we are moving to the end. Basically, the last thing that a server will do is terminate. Terminate is something simple, right? You simply delete it. But there are things we need to think about. Basically, if you terminate the server, will you terminate the data with it? Or you want to keep it as a backup? Or you want to take the disk and connect it to the next server, right? We know that in the cloud, you don't upgrade servers. You simply take the disk and connect it to a new servers, right? This is the architecture that we are talking about all day. So usually, you take the disk and you keep it as a backup, or you move it to the next one. This is the case when you start losing control of your data, right? Because there's a backup, and there's a backup, and there's a backup for the backup. And all your data is being scattered somewhere. When we, on-premise, if we want to destroy data, it was quite easily. We have control. In the cloud, it's not that simple. So how can we make sure that nobody can reuse those backups? Nobody can attach this volume and maybe do some deep scanning and find it? We simply destroy the key. This is called, the technology is called the crypto shredding. The idea behind it is simply, if you want to destroy something in the cloud, encrypt it and destroy the key. Sounds simple, it's not that simple, because when you encrypt it, you have to make sure there are no remnants, and you have to make sure that you really shred the key. But the idea is, we have a key, we have backup disk. Once we kill the key, make it disappear, then the backup disks are useless, and nobody can attach it and use it against us, just like the browser stack did. So this is the last thing of the server. This is the last thing we will do with the server. Destroy the encryption keys and terminate it. And this is the last phase. We don't have a demo for that. It's basically depends on where you store your keys. So in order to summarize, in a couple of words, cloud is moving fast. IaaS is moving fast. It's changing the way we develop and maintain applications. And the programmers, the developers, the architects have already learned to use those cloud advantages. They know how to use the orchestration layer. They know how to automate deployment of software. They know how to automate the APIs to use it for their own good. Us, the security guys, we need to adopt the same methods. The cloud, along with its risk and attack vector, bring a lot of new technologies. Exciting stuff. Stuff that we were not able to do on-premise. It's a new environment. It's a new technology. It gives us cool things to use. Learn how to use them. Because old security techniques, such as maintenance window for patches, vulnerability scanning, stuff like that, simply don't have place with this new architecture of applications. Servers are coming and going. We don't have time for maintenance window. We need to do it when they begin, when they launch, and automate the entire security lifecycle. So this is what This is the message that we wanted to give you. You can do it on your own tools. You can do it with Cloud the Figure. We will be happy to get contributors or people to use it, tell us what they think, tell us if it's okay, if it's matching the needs. Everything is on GitHub. You can simply clone it. I guess Nir will probably explain in 2 words how to do it. And this is about it.
So just a few words about contributors. So all of you know that it's an open source tool. You can download it. You have the link on the deck, or I will publish the link to the Cloud of Figure on my Twitter after this talk, so you'll be able to follow me or Moshe, and then we'll just publish that. Regarding contributors, we'll be happy to get few of you to get ideas. You don't must to check into the code. You can just bring us new ideas. Maybe you can assist us with documentation because we have new API. We want to maybe improve that a little bit. We want to make that pretty cool product that goes to production. We're already speaking with few companies, but eventually we wanted to make kind of cool product. That's all. That's all the purpose that we have. Any questions? Yeah. So the question where that Amazon supporting a lot of operating systems, and you are asking which operating system are we using,
no.
Right?
What kind of hardening?
Which default?
What kind of hardening do we use? Okay. So let's take the word hardening into a couple of different things. Okay. First of all, everything we do for like patching and creating the encryption, all of this goes into one hardening, and we talked about. There is also the question of how do you harden the operating system according to best practices, stuff that are not related to cloud. What we did here is we take a predefined chef recipe that is called hardening Ubuntu. You can find recipes like that for any other server's operating system you want. So it's very easy. And again, if you're using a different configuration management, simply use their recipes.
If you wish to integrate it into the Cloud of Figure, we'll be happy if you'll join us as a contributor and add it.
Any other question, guys? Yeah.
Well, full disk encryption can be slow. It depends on how you consider that. So you can use specific algorithms, or you can even partition your volumes. So let's say that the application can run on one volume, which is not encrypted, unless your intellectual property is important somehow, and you have the database. So for the database, it may be slower, but that's one of the ways that today you handle PII data encryption, because you need to search data. How you handle it? You handle it by full disk encryption. You can do, however, in this chef recipe, if you integrate it inside of the DevOps, you can say, okay, so I'll just do encryption on specific file or whatever you define. The thing is that it's open. You can add it whatever you want.
I'll answer a question in a more general view. Virtualization slows things down by 5 to 15%. Encryption will add probably some more percentage. The way to deal with it is simply build more servers. I mean, this is the cloud. You can very easily launch 2 servers instead of 1 and get double the capacity. Only architect your environment accordingly. So if on-premise you used, I don't know, this kind of disk, this kind of CPU, and this kind of RAM, use double like that in the cloud because all these extra layers. Now cloud provider will also help you. They have new SSD disk, and you can set the amount of transaction per second, I/O per second. This is how they deal with it. Sorry.
Bless you.
Any other questions, guys? Thank you very much.
Thank you.